Ever found yourself staring up at the night sky, consumed by the question, what was there before the universe? It's a curiosity that echoes in the hearts of many, a question as vast and complex as the cosmos itself. Theories abound, each more intriguing than the last, from infinite cosmic cycles to parallel universes. Yet, the answer remains elusive, shrouded in the mysteries of time and space. This question has puzzled humanity since the dawn of time, and today, we'll delve into it. Imagine nothingness, absolute void. That's the closest we can get to understanding what was there before our universe. It's a concept that's almost impossible for us to fully grasp. A state where there is no space, no time, no matter, no energy, just pure, unadulterated nothingness. This is the blank canvas upon which the masterpiece that is our universe was painted. This idea of absolute nothingness isn't just a philosophical musing but a concept rooted in the laws of physics and cosmology. The laws of physics as we understand them break down when we try to rewind the clock to the very beginning. We find ourselves in a realm of physics where our conventional understandings no longer apply, a realm that is still largely unexplored and where the line between existence and non-existence becomes blurred. In this pre-universe void, the seeds of our universe were sown. Theorists propose that even in this state of nothingness there existed quantum fluctuations. These fluctuations are minute variations in energy levels that exist due to the inherent uncertainty in quantum mechanics. They're like a restless sea, constantly churning and roiling beneath the surface of reality. And here's where it gets really interesting. These quantum fluctuations may have given rise to our universe. Picture a tiny bubble of space and time, birthed from these fluctuations, expanding at an incredible rate. This is the concept behind the Big Bang, a singularity expanding into the universe we know and inhabit today. But wait, there's more. Some theories suggest that our universe isn't unique, that it's just one of many, in an endless sea of universes, each born from its own quantum fluctuation. This is the multiverse theory, a concept that takes the idea of existence to a whole new level. From this absolute void, our universe was born. An event that took place nearly 14 billion years ago, giving rise to the cosmos we call home. From absolute nothingness to a universe teeming with galaxies, stars, and planets. A journey of cosmic proportions, born from the void. Around 13.8 billion years ago, something extraordinary happened. The universe began. Picture a moment so intense, so cataclysmic, that it gave birth to all of time and space. That's the Big Bang for you. The Big Bang Theory, the leading explanation about how the universe began, suggests that it started as an incredibly hot, dense point, roughly equivalent to the size of a subatomic particle. This is the initial singularity, a concept that may seem perplexing. But let's break it down. A singularity is a point where some property is infinite. In this case, we're referring to density and temperature. Imagine the entirety of our universe, all the galaxies, stars, and planets, compressed into a space unimaginably small. That's the singularity we're talking about. And in that tiny, dense point, the seeds of our universe were sown. Then in a moment smaller than the blink of an eye, an explosion occurred. But this wasn't your average explosion. This was an explosion of space itself, an explosion that created what we know as time and space. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy. And it's been expanding ever since. From this initial singularity, the universe exploded into existence, expanding at an incomprehensible speed. Matter, energy, space, and time all came into being in an instant. And within a tiny fraction of a second, gravity and all the other forces were formed. In the immediate aftermath of the Big Bang, the universe was a hot, dense sea of particles and energy. As it expanded, it cooled. Matter began to coalesce into the first particles, which eventually led to the formation of atoms, stars, galaxies, and much later, planets and life as we know it. And just like that, from a singular point, our universe exploded into existence. The Big Bang was not just an event in the distant past, but a process that continues to shape our universe to this very day. Post-Big Bang, the universe was a hot, dense soup of particles. It was from this chaos that order slowly began to emerge. In these early moments, our universe was a frenzied dance of subatomic particles, colliding and interacting in a rapidly expanding space. But, as time ticked on, the universe cooled. This cooling was a game changer, as it allowed for the formation of atoms, the building blocks of matter. Imagine the universe as a giant cosmic kitchen. In the heat of the Big Bang, all the ingredients were there, but they were too hot and chaotic to combine. As the universe cooled, these ingredients began to mix and bond, forming hydrogen atoms and later helium. These were the first atoms ever formed, the first step towards the complexity of the universe we know today. And what did these atoms do? They did what atoms do best. They clumped together, attracted by the force of gravity. Over millions of years, these clumps grew larger and larger, eventually forming stars. These stars then grouped together into galaxies, vast cosmic communities that are the backbone of our universe. But how do we know all this? How can we be sure about events that happened billions of years ago? The answer lies in the cosmic microwave background radiation. This is the afterglow of the Big Bang, a kind of echo from the very early universe. By studying this radiation, scientists can peer back in time, all the way to when the universe was just a few 100,000 years old. In essence, the cosmic microwave background radiation is the universe's baby picture, providing us with crucial clues about its birth and early development. It's a testament to the power of science that we can use these faint whispers from the past to understand our universe's history. From chaos, stars were born, galaxies formed, and the universe as we know it took shape. This is the story of how, from a hot, dense soup of particles, rose the vast and beautiful cosmos we call home. In this vast universe, where do we stand? After the Big Bang, about 9 billion years passed before our solar system was born. The collapsing cloud of gas and dust gave birth to our sun, and the leftover materials orbiting around the sun gradually formed the planets, including our home, Earth. Life on Earth began as simple, single-cell organisms, and over billions of years, it evolved into a symphony of biodiversity. About 6 million years ago, the first hominids, our ancestors, walked the African savanna. Modern humans have been around for a mere 200,000 years, a blink in the cosmic timeline. Now consider this. The universe is about 93 billion light-years in diameter, and our Milky Way galaxy is just one of 2 trillion galaxies out there. Our solar system, a small part of the Milky Way, and Earth, a mere speck in the universe. Yet here we are, sentient beings on a tiny planet, capable of pondering the universe and our place in it. We have developed science and technology that allows us to look back across cosmic time to understand the universe from its earliest moments to its far future. Our existence may be minuscule, but our ability to comprehend the universe is immeasurable. Our curiosity and thirst for knowledge make our existence significant. In this grand cosmic drama, we are but a speck, yet we're capable of understanding the universe's story. The universe's story didn't end with us. It's still being written. Every second, every minute, every hour, the universe expands like a cosmic balloon inflating with the breath of time. This ceaseless expansion is not just a journey outward, but a journey forward into the future. And what does this future hold? Theories abound, each as fascinating as the next. Consider the Big Freeze, where the universe expands until stars exhaust their fuel and all becomes dark and cold. Or the Big Rip, where the universe expands so rapidly that even atoms are torn apart. And then there's the Big Crunch, the idea of universal contraction leading to another Big Bang, a cyclical cosmos reborn again and again. Yet, these are just theories. The true shape of the universe's future is as mysterious as its past. As we continue to explore and understand, remember we are not just in the universe, but the universe is within us.